Next, we demonstrated the use of subqueries in the from clause of the main query, generating a record set that forms the basis for that outer query. One typical use is for computing aggregates within aggregates, i.e. finding nested aggregates. To find the average number of products and quantities across all orders, we first find the number of products and total quantity of each order. That is the inner aggregate operation. This one is easy to imagine. If an order has multiple line items in our sports example, the number of products is the number of line items, and the total quantity is the total number of different products ordered. We could have used the total dollar amount just as well. So, the inner query generates a record set of orders with product count and total quantity of products ordered, which serves as the basis for the outer or main query. The size of this record set is 1,331, or the number of orders. Each order has an ID, customer ID, first, last, and then number of products and total quantity. Of course, the customers repeat because quite a few of them have placed multiple orders, so this record set is then used in the from clause of the outer or main query to find the average number of products and average quantity by each customer, resulting in a table with 322 rows, one per customer. Okay, so I'm going to um, MySQL 7 underscore 03 underscore subqueries 2 right after that test for the Bob Heinrich that we did in the end of the previous video. And we are going to do this one completely from scratch. And I'm going to try to emphasize some of these points I just made in the intro part of this video. All right, the select statement resulting in a record set to be used in the from clause of the outer query can and should be tested independently first, and then folded into the outer or main query. So let's try to do that. So we'll start first by a couple of blank rows. Select orders dot order ID, comma orders dot customer ID, then customer dot first name, customer dot last name, comma count as num prods, sum of quantity as TOTQTY or something like that. Okay. So this is going to be then selected from orders inner join order detail on orders.order ID order detail dot order ID. Okay, I'm going to put that in parentheses, and we're going to inner join that with customer on customer dot customer ID equals orders dot customer ID. I'm gonna close that one, and finally we're going to then group by orders dot order ID and customer dot customer ID. Okay, so we're going to save this and test that. All right, so we have ourselves if there's no errors, of course there is, first name Frist. Okay, Frist, collecting the spelling of first name, should run. Yep, we got 1,331 orders from 1 through whatever, right? Whereas the we have 322 customers repeating here, all right, and we have then the total number of products ordered per order and total quantity of these different products, right? So 3 different products, total quantity of 23, 2 different products, quantity of one each, so total quantity of two, and so forth and so on. Okay, so this becomes the basis for the outer query. So if we back up to the code, this becomes the basis for the outer query. So the outer query, okay, is going to select, we're going to give this entire inner query here a name. I'm trying to line it up again. ORDAGG, order aggregate. I'm going to use that alias ORDAGG dot customer ID, ORDAGG dot first name, ORDAGG dot last name, comma, and then we're going to average ORD. This is the new piece. This is the new piece. We're going to average the number of products, right? Okay, so this is this nested aggregation process, right? The number of products from the inner query is already an aggregate by virtue of using the count function, and now this is the the aggregate of the aggregate, as you will, and we're going to call that one what? AVG num prods, comma, and then we're going to do the same for total quantity as AVG quantity. Okay, and then we have the from, open parenthesis, delete the close parenthesis, and then put the close parenthesis at the end. At the end, and that should be called, this should be called order aggregate, not this piece. So I might have some extra parentheses here. Hopefully you'll see. That matches that one. I think I was right. I think this should have been here. And then we're going to group by, I don't think I need this. I do not need this parenthesis, right? Okay, I just got a little confused on parenthesis. Group by ORDAGG dot customer ID, and I can put the first and last name as well, but this should do it. Okay, save, copy. Okay, so this is giving me the 322 customers. 322 customers, and the average number of products and average quantity. You should probably clean up this output, but that's not something we're going to be doing in this video. Okay, back to the presentation. Okay, the last type of intermediate level SQL problems, where is the presentation? Here, right here, second bullet. Our so-called nested queries involve the so-called division operation. Here, the rows from the two tables in the many-to-many relationship are combined in a way that values from a column in the first table are associated with all the values from a column in the second table. And the first and the second are the two involved in many-to-many relationship with the associated with the table in between, of course. So, what we want to do in the next example is create a list of customers that took advantage. Well, this is just one of the examples. List of all customers that took advantage of all promotional offerings in our store is one such example. List of employees that have taken orders for all products ordered from a given group is another, and this is the one at the bottom of the slide we're going to try to implement. Okay, in this example, the key is to understand the use of subquery in the having clause. So far, first we've used it in a where clause the most. Last example show you how to use subquery in the from clause, and this is the example is going to show you the use of the subquery in the having clause. The main query joins employee, as is shown down here. Let me scroll down. Joins the employee with orders, order details, and products. Okay, the where clause restricts the products to the hockey gear. Okay, the groups by the employee. Okay, but the having clause is the one that's tricky. The one that's left, of course, empty here. Okay, here the count of distinct product IDs in order details over here from the orders taken by given employee have to equal to the count of distinct product IDs from all order details that contain hockey group products. And that's the hard part, again, to understand and be able to implement. Okay? Although this is a type 2 query, or subquery, because the subquery uses order detail table in the main query as well as in the having clause, as you'll see in a second, we can test the subquery separately because it will always return the same single number. You'll see 5, as in 5 hockey products. We've seen those before in another example. Every time this subquery is called by the outer query. Okay, so we'll start by counting distinct product IDs from the order details table interjoined with product for hockey gear product group. Okay, so that's the first thing we're going to do. All right, so let me go couple of empty rows. Okay, let me start by selecting the count of distinct order detail dot product IDs. Okay, from order detail dot inner join product table on order detail dot product ID is product dot product ID, where prod group is hockey gear. Okay, so let's start with this one. Okay, let's start with this one. We can obviously copy this, paste it, and if there's no mistake, run it and see that number 5. So there are 5 distinct order IDs, okay, product IDs rather, from order details, all order details in this entire database, right? In other words, simply put, all 5 of those hockey gear products were ordered. I'm sure at different amounts by different customers, taken by different employees, all that stuff, but all 5 were ordered. This is what, clearly sort of shows that. Okay? Now, the having clause then count distinct order detail dot product ID. Okay? So, these guys here, right? These guys are coming from all these inner joins of employees with orders, order details, and products, right? So these are the distinct, okay, product IDs, ultimately through all this web of, joins that are, processed, I suppose, are taken by the employees, okay, by different employees, over different, span of time. And if that count matches 5, which is really the total number of hockey gear products, as we just displayed. We had to do this query because we don't know. Maybe there was a hockey gear product that was never ordered, right? And then it wouldn't work. But so just simply think of this as 5. And then if the employee took all 5 orders, that's the one that we want. That's the division example. Okay, so then this, okay, has to match with that. And we're gonna put this again. Okay, one more line, parentheses. Okay, so again, you would imagine that the majority of employees, right, taking orders, including orders for the hockey gear, would not have handled all 5 of these different hockey gear products. Okay, but some might, and those are the ones we want. All right, and those are the ones we want. So we're going to highlight this. Hopefully there's no mistakes. We'll run it, and let's see there's only one. Out of 97 employees, there's only one Gustavo Henderson that has handled all five of those hockey products, right? There probably were others that were, handled or taken some of the orders for some of the hockey gear products, but not all five of them. Okay, now checking this result is not as straightforward, but what we'll do, we'll run the last query in the file here that's called checking the result. Okay, we're going to run the last query in the file that will select all the employees that took hockey gear orders. Okay, simply, right? And we'll run it and we'll copy, paste the results into some Excel, empty Excel file. Okay, once the file opens, we're gonna paste this, right? Make it a little bigger. Okay, make it a little bigger so you can see it. The scroll bar doesn't work. Okay, and then what we're gonna do, we're going to simply quickly run the pivot table on this and put it right here someplace, maybe a couple other rows, and then we're going to put the employee ID on the row labels and the product ID on the columns and change the summary to count. Okay, so let's change the summary to count, and then again, what we'll do is, so in order to sort of not look at these one by one, we'll do a check here saying if the count, which is in F2, is 5, then we want to sort of filter that out. Otherwise, I don't know, we can leave it blank or whatever, 0, doesn't matter. Okay, first of all, if you look at the sum, there is only, the sum is 1, which means only one has taken all 5 orders. That's employee number 90, which is our, where is it? Right here, Gustavo Henderson. Okay. So, although 45 out of 97, or about half of the employees, took orders for hockey products, right? The 45, where is that? It's right here. If I highlight this, the count is 45, right? Okay. So about half of the employees took orders for hockey. Only one took orders for all 5. Is the conclusion here. Okay. So I'm going to switch back to the presentation and pause.